This is Programme 6 of VideoTell's series on practical marine electrical knowledge. The series is made up of 8 programmes. Programme 6 deals with special electrical practice relating to vessels designed to carry flammable cargo. It also aims to develop a greater awareness of the safety elements and design features built into the electrical system of such ships. We shall also show the special electrical equipment certified for use in hazardous areas, demonstrate the servicing of a flame-proof light fitting, and the method of fitting a cable gland to a flame-proof motor. There are many system variations around, so it is most important that you become familiar with the components of the electrical system and the layout of the main switchboard immediately you join a ship. Pay particular attention to the layout of the emergency switchboard. This study will pay dividends during a blackout or when troubleshooting the cause of a major breakdown. Now we must emphasize electrical safety. The golden rule is, before any work is done on an electrical installation, first isolate the circuit by removing the supply fuses or locking the circuit breaker in the open position so that the circuit cannot be energized accidentally. Then post a warning sign to alert others that the circuit is being worked on. Then prove the circuit dead with a voltmeter or an approved line tester. A switchboard can never be considered dead unless all AC generators connected to it are stopped, locked off, and all other supplies are disconnected. These points can never be emphasized strongly enough. The electrical rescue procedure is described in Programme 1 of this series. A variety of instrumentation on board ship guards, controls or monitors the ship's functioning. The red shaded areas on this drawing show the hazardous areas relating to the electrical code of practice, which is the subject of this programme. Generally they are cofferdams next to cargo tanks, compressor rooms and pump rooms, and about a 3-metre periphery surrounding all outlets for the flammable cargo. As far as the electrical system is concerned, the problems here relate to the cables going through these areas and the servicing of electrical plant operating therein. Also, they involve the use of intrinsically safe electrical instrumentation and equipment. As a general recommendation, hull returns and neutral earth systems are not normally allowed except in the case of some high voltage systems of 3.3 kV and above, where the circuits are not allowed in any dangerous area. Also, the generating plant, switchboards and battery systems must be separated from the cargo tanks by a gas-tight cofferdam. Cables laid along the foredecks should be installed in steel piping in such a way as to allow for any structural movement of the ship without strain or chafing. These rectangular expansion boxes house a loop in the cable runs to allow for expansion. The piping to and from the boxes also allows for the expansion movement of the ship. Through runs of cables may be permitted through pump rooms, cofferdams or enclosures next to cargo tanks, provided they run in heavy gauge steel piping with gas-tight joints. Cables which are associated with intrinsically safe equipment must be separated from all other cables and clearly identified as such. Here, the blue color code is used. They will have their own separate power supplies and a Zener protection barrier. The Zener barrier ensures that the maximum preset voltage in the circuitry cannot rise above the prescribed safety level, which ensures the certification of intrinsically safe, EXI. EXI, or intrinsically safe equipment and circuitry, has a protection technique which confines the energy within the system below a level which is capable of causing an explosion in a dangerous atmosphere. EXD certified equipment is flame-proof and relies on the integrity of its encasement to withstand any internal pressure of an explosion without any flame being emitted. EXP type equipment, on the other hand, is equipment which is protected by a pressurized inner atmosphere made up of air or inert gas. This prevents the possibility of a dangerous air-vapor mixture entering the enclosure of the electrical apparatus. Examples of these are seen here. Light fittings in hazardous areas must be of flame-proof or pressurized types. These light units must be on at least 2 independent final branch circuits, so that one may be disconnected for maintenance, while the other supplies enough light for safe access. Switches for these lights must be double pole, interrupting both supply lines, and must be situated outside the hazardous area. The maintenance of a flame-proof light fitting involves 2 specific objectives. First, the prevention of any deterioration in the equipment's safety level, and second, ensuring its correct, safe function. Use only non-abrasive materials for cleaning. Lightly grease, then wipe clean the flanges before fitting them together. Periodic maintenance inspection and cleaning will necessitate the inspection of all flanges, glassware and cementing to ensure that they are within the certified safety level. If either the cementing or the glass envelope appear damaged, do not try to mend or replace either. The whole fitting has to be replaced by a new part obtained from the manufacturer. It's important to remember that there is a great deal of difference between flame-proof and weatherproof fittings. Do not put a gasket between the flanges of a flame-proof fitting to make it weatherproof. This will invalidate its flame-proof certificate, as will any other modification of the original design. When reassembling these types of fittings, extra care must be taken to ensure that the flanges are clean. The special flame-proof cable gland must be checked for tightness and the electrical connection made. Again, ensuring that the conductor is held tightly in the terminal box. There must be no loose wire strand left in the terminal box. Solder the strands of a multi-strand conductor to eliminate the possibility of short circuit and ensure a secure connection. When tightening any bolts or nuts holding flanges together, the force used should not be more than necessary to prevent loosening by vibration. Excessive force may cause undetected fracture of a bolt, a casting, or other parts of the securing mechanism. If a broken stud has to be removed from a blind hole, great care must be taken to avoid damaging the internal thread or drilling through into the flame-proof enclosure. Broken or missing screws must be replaced by ones of the same diameter, thread, length, type, and quality of steel. Finally, check once again that the flame-proof gland is correctly tightened. Remember, the installation must not be changed in any way for any reason, as this may invalidate its certified safety level. Electrical motors which drive cargo pumps or compressors are housed in the motor room and they're separated from the compressor room by a gas-tight bulkhead. The drive shaft has to be fitted with gas-tight glands where it passes through the bulkhead. The motors are required to be the pressurized type or increased safety EXE construction. The starters and the control gear for these motors must be housed elsewhere, outside the hazardous area. The motor room is pressurized so that gas or vapor may not enter the airspace where the motors are operating. Entrance to the motor room is through a system of double doors controlled by a pair of micro switches and a safety light indicator. The system should ensure that one door is opened only when the other is shut. When a cable run is laid to a flame-proof motor, special attention must be given to the preparation of the cable end and fitting the special flame-proof gland onto the cable. Here, the required length of the outer sheath is stripped off to reveal the steel armouring. Allow plenty of time for this work and use sharp tools. The armouring is then cut round with a wire cutter and pulled off. A further short piece of the outer sheath is stripped back, as you see here. This will free a further length of armouring, which will be clamped between the double rings of the gland for tight and secure fitting. Use special flame-proof glands which have longer threaded flame paths and rubber seal rings with extended hold on the cable, forming another flame path. Carefully dismantle the cable gland and secure the threaded base unit in the terminal box. Fit the lock nuts on the cable then the double rings for gripping the steel armouring. Fit the conical rings below and above the loose armouring, like this, ready for tightening. Temporarily remove the rubber seal ring from the terminal box port and feed through the cable. Tightening the two pressure fittings with a spanner. This will ensure that the two conical rings grip the armouring tightly. Remove the cable from the terminal box and replace the rubber seal ring. Prepare the conductor ends for receiving the terminal lugs and feed through the cable again into the terminal box. Now the conductor ends are fitted into crimped lugs and the cable connected to the terminals. Check that the lugs hold the cable tight so that they will not vibrate loose when the motor is operating. Nuts are tightened sufficiently to avoid becoming loose due to vibration. Finally, check their labels to ensure that all portable apparatus, such as portable radios, torches, or insulation resistance testers, are specially approved intrinsically safe types, certified for use in hazardous areas. If you use portable electrical equipment or tools, ensure that their connections and cables are sound and safe to use in the area in which you intend to use them. This concludes the subject for Programme 6. Here we dealt with the special electrical safety design features which are built into a vessel designed to carry hazardous cargo. We have dealt with the essential difference between general electrical practice and specific electrical practice in hazardous areas. We have seen how to service a flame-proof light fitting and how to prepare the cable and cable gland for a flame-proof motor. Emphasis was laid on maintaining the equipment's certified safety level at all times. This is the most important single difference between working on equipment for use in hazardous areas and other general electrical installations. And lastly, we dealt with the use of intrinsically safe portable equipment. We recommend that you watch this program again and that you consult the book Practical Marine Electrical Knowledge, which accompanies this series and will allow you to study certain aspects in greater detail. Finally, here's a list of contents for all the programs in the series.